Hey pre-calc friends, today we're going to talk about section 3.4, which is the last section of our chapter, and it's a big one. It helps us to find out how can we solve these big equations. For example, can we solve exponential equations? And then we're also going to talk about how can we solve logarithmic equations as well. So this section is very, very important in terms of just helping us how to solve, because once we know how to do that, then we can apply it to stuff in real life, like archaeology and other cool things that we'll do a little bit later. So this will be a really important section for us and really a fun one too. So let me define a couple things before we move on. First of all, if I talk about an exponential equation, it's obviously an equation, right? But exponential because the variable that we're looking for is in the exponent. So for example, 3 to the x, or 5 to the x, or even e to the x with our special natural number. But now let's make an equation. For example, this first one here, I have 2 raised to the x equals 8. If you see, the variable is in the exponent, right? So that's called an exponential equation, and we need to solve that for x. Now some of them, as I get a little hint over here, some are kind of easy to do because all we got to do is try to match the base on the left with the number on the right. Meaning right now, if I look at example number 1 and I say, friends, what can I raise 2 to? 2 to what power gives you an 8? You can say, well, see, 2 to the 2 times 2 to, okay. So maybe if I raise 2 to the 3, I think that gives me 8, right? So then you can say, all right, well, therefore x equals 3. X equals 3. 2 to the 3 is 8. Or another way to do it that could be really useful is try to match both sides with the same number. Meaning, do you see how the left has a 2 to the x? Can you take the bigger number on the right and rewrite it in terms of this same base? That's a base of 2, so can you rewrite 8 in terms of 2? Well, what is 8 in terms of 2? It's 2 to the third, right? So that's a really good idea. Why don't you rewrite it so that they have the same base? If you think about it, if the bases are the same, what do you know has to be true about these exponents? They're also the same, right? So if you can match bases first, then you can match the exponents and solve. So therefore, x and 3 have to be the same. So I can also say, well, x equals 3. So we solved it twice. We did it by just doing a little bit of mental math over here and saying, all right, 2 to what power gives you 8? Oh, 3. Or another great idea, as you sit over here in a little hint, is matching both bases on the side and solving the exponents. Let's try number 2. Number 2 is kind of hidden right over here. Ready? Here's number 2. 3 to the x minus 2 equals 27. Okay, let me write that down here on the right-hand side so you can see it better. Now, if you try to do the mental math way, this might be a little harder. It might take a little bit longer. So why don't we try the second idea? Why don't we see, can we match the bases on both sides? And the best thing to do is try to take the bigger number and rewrite him in terms of the smaller number. Don't rewrite the smaller in terms of that number, because that's just hard. So try to take the bigger number and rewrite him in terms of the smaller number. So I'm going to keep the 3 to the x minus 2 the same. But I'm going to try to rewrite the 27 in terms of 3's so that these guys match. Okay, can you think about 27? What is 27 in terms of 3's? 3 to the 1, 3 to the 2 is 9, 3 to the 3 is 27. Okay, there we go. So 3 to the third. There we go. So on these very simple exponential equations, folks, if we can just match the bases, then look what we can do. Since the bases are the same, you have a 3 and a 3, you can match the exponents. So why don't we make this into a little equation? Because again, if the bases are the same, the exponents are the same. So you guys can say x minus 2 equals the other exponent, 3, and solve. And there you go. So to solve these very basic exponential equations, try to see if you can match the bases on both sides. Okay, that's example 1 and example 2 for you. Great. But the problem is, okay, well, what if we have to do something like this? What if I have to try to solve 2 to the what power equals 100? Now, if you think about it, if I try to raise 2 to a power, what do I have to raise it to get kind of close to 100? Do you know? Like 2 to the first is 2, 2 to the 2 is 4, 2 to the 3 is 8, 4, 5, and I keep going, and I think it's going to be somewhere between 6 and 7, I think, because 2 to the 6th is 64, and 2 to the 7th is 128, so I think 100 is in between 6 and 7. So I bet x is probably somewhere between 6 and 7, like, I don't know, like 6.5, for example. I don't know. But this is going to be hard to do because I can't match the base. I can't write 100 in terms of 2 to the, because you can't raise 2 to a power and get exactly 100. So this method of matching bases, it don't work here. We need to find another way. Well, in this last section, as you guys learned the log laws, we've talked about the idea of taking a log equation and freeing a variable by doing this. Ready? Log base 6 of x equals 2. All right, well, can you rewrite that into exponential form? Let's see. Getting rid of the log, we talked about these arrows, right? 6 raised to the 2 equals the x inside the log. Okay, 6 to the 2 equals x. Oh, there we go. And 6 squared is just 36. So if you're in log form, you want to switch it to exponential form. Yay! And I feel like later on, in order to solve these harder exponential forms over here, we're going to need to change this into log form later. And we'll try to figure that out in our next lesson. But right now, if you're in log form, the best thing to do is switch it from log to exponential form. Okay? So try to figure out which form you're in, and more likely than not, you're going to switch to the other form to try to solve. Let's stick with these for a little bit before we go back to that 2 to the x equals 100 and try to figure him out. Can we try each of these, friends? Let's try if we can solve number 1, 2, and 3. These are log equations, and you're going to switch them back into exponential to try to solve. And again, just think about those arrows that we drew last time. All right, let's try number 1. Let's do number 1 together, and then I'll show you 2 and 3 that maybe you can try on your own. Okay, number 1 is a log equation, first of all, because it's in log form. You see the log, you see the equal sign, so it's an equation. Okay, so we know what we're doing. We just need to solve for the x here. Okay, well, let's rewrite this friend into exponential. I don't see a base, though. Do you see it? Oh, it's empty, so it's a 10. Ready? Here comes the arrows. 10 raised to the equals that whole inside quantity. Ready? Here we go. So let's get rid of the log and write 10 raised to the equals whatever was inside the log. Well, yay! Good job. You see how the x has been freed from the logarithm. This is great. Let's just keep going. What's 10 squared? Awesome. And we can just solve now by dividing both sides by 3. So I'll just say 100 divided by 3, which I don't think reduces any further than that. I'll just leave it like a nice little fraction there. Okay, so that's basically what you're going to do, is try to take number 2 and 3 and rewrite it into exponential form. Here's number 2, and here's number 3. Can you rewrite those on your own into exponential form and try to solve for x? Go ahead and pause the video and try on your own, and I'll meet you back here in a minute. All right, are you ready, folks? Hopefully these went okay. I kind of like these kind of problems. They're not really too difficult. Just got to know which form you're in and which one to switch it to. Number 2, I'm in log form. I need to switch it to exponential. So I got my arrows going. Ready? 2 raised to the equals the entire inside, whatever's inside the log, this whole parenthesis here. Here we go. Let's write it out. 2 the base raised to the equals the entire quantity inside the log, right? All right, now we're just back to algebra 1. Let's just solve for x. 2 cubed is... And let's just start isolating the x. Adding 1 and dividing by 3. And there you go. Now, this is algebra, so we could actually go back and double check our answers. Ready? Here's what we can do. Let's plug the 3 back in and see if it makes sense. Back into the original equation. Ready? Log base 2 of 3, x you found was 3, minus 1. Does that, let's check, does that equal 3 on the right-hand side? Well, let's actually simplify inside the parentheses. Ready? This is log base 2 of 3 times 3 minus 1 is 8. Does that equal 3? And it does. 2 to the what power gives you 8, and it is 3. So we can always double check our answers on these. That's great. All right, number 2 is good. How about number 3? Okay, we're in log form again, but what kind of log is this? Let's see the ln. Oh, it's a natural log, right? Natural log has the base of e. There we go. Got your arrows? There we go. E to the 7 equals 3x minus 4. Now, if I ask you to do this without a calculator, it's going to be a little hard because what's e to the 7? I don't know because e is a decimal, right? So why don't we just treat it like a variable and just leave it like it is? Let's just work around e to the 7 and leave it in there without a calculator. Okay, same steps. Let's add 4. That's literally e to the 7 plus 4, whatever that is. And then finally divide by 3. And there you go, friends. So whenever we see a log equation, you're generally going to switch it from log into exponential, and that can solve it. So when we come back later and try to get this big guy up here, how do you solve this if I can't match the bases like I did on the top of the page in the beginning of today's video? How do I do that? Well, if you're an exponential, what form do you think we need to switch it to? When you're an exponential, we're going to switch it to log form. And we're going to learn that next time, folks. So great job. Good introduction to section 3.4, and have a good rest of your day. See you next time.